All right, hello everyone. We're in unit, oh gosh, I need to change that. This should say unit 11. Circles. Section, now this is in chapter 10 in your book though. So we're starting with section 10.7, which is writing equations of circles. In here, let's look at, on the right over here, is a circle. And so if you look on the coordinate plane, if you have any point, x, y, coordinates are x and y, on a circle, so that point, right out here on this circle, how do I find the equation of this circle? This point on the circle, so anywhere around the circle, if my center is at the origin, and I have a radius of r, so along that red line you can see r is the radius from the center of, from 0, 0, the origin, to the point on the circle is the radius. Now, how do I figure out the length of r? Well, we've used Pythagorean theorem. But what this gives me is an equation. If I square x and I square y and add them together, you know that I will get the square r squared. So x squared, that's the distance here on the bottom, plus y squared, that's the distance up here, is going to equal r squared. So that is the equation of a circle with the center at the origin. X squared plus y squared equals r squared. That will give me any point along this circle. If I know an x value, I can plug it in. If I have an x value over here, I can plug it into the equation, and I will end up with the y value. I can solve for y if I want to and figure out what the y values would be for that x. Remember, when you take the square root of a number, you get the plus and the minus. And so that's how we would get both of these points if I put that x value in. Okay, so I'll clean that up a little bit, so if you want to take a look at that, you can. Now, let's look at writing the equation of a circle. If I'm centered at the origin, this is the equation you need to know. X squared plus y squared is going to equal r squared, the radius squared. Make sure you understand radius is squared. Radius is squared. Okay, so let's look at this example. We're going to write the equation of this circle. Notice that from this center, 0, 0, right there at the origin, if I go 3 up, 3 to the right, let me show you what I'm looking at. If I go 3 units up, 3 units to the right, 3 units down, 3 units to the left. So in any direction I go, up, down, left, or right, I've gone 3 units. And so that's my radius. My radius is 3. So if I'm going to write the equation of this particular circle, again, it's centered at the origin. So my equation would just be x squared plus y squared equals the radius squared. So let's look at, we've got r is 3, so let's square the radius, and the radius squared is 9. And there's the equation of that specific circle. X squared plus y squared equals 9. So with that given radius, 3, and the center at the origin, I can pick an x value anywhere on here, plug it into the equation, and I'll be able to figure out exactly what the y values are that correspond to that specific x. Okay, so when we're at the center, when the center of my circle is at the origin, those equations aren't too difficult. But now let's look at the standard equation of a circle when we've moved the center point around. We translated that center point around. And so now we're going to have a center at HK. And you're going to start seeing this term, this HK, a lot as we move on into Algebra 2. So it's a good idea to start learning what this HK means now, where H and K are the coordinates of the center point. H and K will be the coordinates. Make sure you understand that in the equation we say x minus h. Well, all I want is h. H is the center. And so y minus k. The k value is the center. So if you notice from the equation itself, x minus h squared plus y minus k squared equals your radius squared. My center point is just hk. So when I pull the center out, it's going to actually be opposite of the sign. Let's look at what I mean. On this example, we're going to identify the center and the radius. So my center is x minus 3, and so that's already in the form of the standard equation, x minus 3, so I just pull out the 3. That's the x of my center. But now look at this equation, y plus 1, that's not in the standard form, which is y minus k. So I have to take the opposite sign. You can think of that as y minus negative 1. But really what we tell our students is when I have these grouped together like this, my x minus 3 in parentheses, and I take the center out, it's opposite the sign. So I've got 3, negative 1, and both of them are opposite the sign that was in there in the parentheses with them. We take the opposite sign, 3, negative 1. Now, let's think about radius. Remember that this side is my radius squared. And so to figure out what the radius is, we have to take the square root. So the square root is 16. And again, think about that we aren't going to have, when you take the square root, we would end up with a plus or a minus. But in this case, we're not going to have a negative radius. We're not going to have a negative distance. And so here, the radius for this one would be 4. Okay, let's zoom through a few examples here real quick. Write the standard equation of a circle with a center at 0, negative 9 and a radius of 4.2. So remember that we start out, let's write it on this page too. My x minus h squared plus y minus k squared equals radius squared. That's our general form of the equation. So let's plug this in. We've got x minus the h value, which is the x of your center point, so x minus 0 squared, plus y minus k, but remember my k value here is negative 9. That's the y value of my center point, equals 4.2 squared. And if you square 4.2, you get 17.64. So this is really the form of the equation, the x minus h squared plus y minus k squared equals radius squared. This is really the good form of the equation to learn. Because if I'm at 0, 0, and I plug 0 in, take a look at this first part right here. If I plug 0 in, don't I just get x minus 0, which is x squared? So if you just remember this form and you plug in 0, 0, you're just going to get the x squared plus y squared. And then I'm going to get plus. Now this one is going to be y plus 9. Yep. Squared equals 17.64. And that is the equation of that line. Let's look at a center of 0, 0 and a radius of 2.5. Now, if you remember the original equation, when I'm at 0, 0, remember that if you put in 0 for h and 0 for k, you just get the x squared. So this one's not too bad. X squared plus y squared, if I'm at 0, 0, equals radius squared. And when I square 2.5, I'm going to get 6.25. And that's the equation. All right, one more. A center of negative 2, 5 and a radius of 7. So my center is going to be x minus the x value of the center, which is your h, plus y minus k, which is the y value, almost wrote k, which is the y value of your center, squared, equals radius squared. So clean that up, and we get x plus 2 squared plus y minus 5 squared equals 7 squared, which is 49. And there's the equation of that circle. Okay, here we have a point, -5, 6, and I plotted it on the circle, or on the coordinate plane, is on a circle with a center at -1, 3. So I'm going to pause here just for a second. I'm going to plot -1, 3. Okay, I plotted it. Now, I tell you this, the pens that I have to use for this are really difficult for me to actually draw good lines. But, so there's the radius. That's my radius. Now, do I know what the length of that radius is? If I'm not parallel with an X line here or a Y, one that's going vertical, there's no way for me to tell the exact distance unless I use, hopefully y'all are thinking what I'm thinking, which is the distance formula. So we're going to have to use the distance formula here. To get my radius, r equals, and we've got to refresh our memory on the distance formula. Let's think about this for a second. The radius is going to equal, remember that, we're going to do x1 or 2 minus, you just got to subtract the x's squared plus, and we're going to subtract the y squareds in the same order. So whichever point you start with on the x's, you've got to start with that one on the y's. So subtract your x's, square it, subtract your y's, square that value, and you're going to add the 2 and then take the square root. So my radius here is going to be the square root of -5 plus 1 squared plus 6 minus 3 squared. I'm going to get r equals the square root of -4 squared plus 3 squared. So r equals, this is, I'm going to write this over here, the square root of, because I don't want to run out of room, 16 plus 9, so I get r equals the square root of 25. Now remember, we're looking for radius, which is a length, so we're going to get 5. So now that I have what the radius is, and I also started out with my center point, I can write the equation of that line. So I've got x minus the x value of the center, so that's going to give me a plus 1 squared. Don't forget to square. Don't forget to put those squareds on there. Plus y minus the y value of the center, 3 squared, equals radius squared, which is 25. Okay, so that's the equation of the line. Sorry, I said line, I meant circle. That's the equation of my circle that has a center at -1, 3. Now, the point -5, 6, what we used that for, remember, is because they gave me a point on the circle, I can come up with what the length of the radius is, and that's how I'm going to get this equation. Okay, last one, this should be quick. Graphing a circle from the equation. So think about the things we need to find from the equation. We need to find the center. I'll write that in coordinates. And then we need to also find the radius. So the center is going to be, remember that what is in here, what's in your parentheses with your x is going to be the x of your center opposite that sign right there. Because we need x minus the h, and the h is just 4. Didn't look very nice, so let me rewrite that. 4. And then the y is going to be what's grouped in here with my y. That is the y of my center opposite the sign. It has to say y minus the k value, and it doesn't. It says plus. So we need to think minus a -2. So there's my center, 4 minus 2. So over 4 down 2, about right there's my center. And then my radius is this, the 36, but remember that the 36 is r squared. And so we have to take the square root of 36 to get the radius, and so r equals 6. Now, how do I graph that? From my center point, I am going to count to the right 6 units, 1, 2, 3, 4. Now this is going to go off a little bit. 5, let's say about there. 6. I'm going to go up 6. 1, 2, 3, 4, 5, 6. To the left. 1, 2, 3, 4, 5, and 6. And then I'm going to go down 6. 1, 2, 3, 4, 5. Okay, so those are, like that last dot. No, and I erased that one too. 2, 3, 4, 5, 6. Guess I should have paused while I did this. And so I've got all my dots. Now, this is going to be hard on here, but I'm going to do the best I can to connect dots. And we want to make sure that when you connect the dots, you make it look circular. They should not be connected with straight lines. You know, that looks kind of straight there, didn't it? Okay, they shouldn't be connected with straight lines. It should be connected in curved lines so that it looks somewhat like a circle. Okay, there you go. That is writing equations of circles and graphing.